This should work now. Okay, cool. Yes, hello. Welcome to the part 7, where I continue the build process of BIP44 compliant air capped crypto vault. So let's start with it. Before that, let me summarize what we were working on and how far we were able to how much ground we were able to cover. Just fetching the right screen. Gotcha. You should be able to see it now. Cool. So earlier we were working on this wallet app here. We we got the UI of it done to a certain extent. Let's take a quick look at that. So this is what we have, and I think we added some handlers on the backend side. Not all of the handlers were done, but we were able to make progress till let's see. These 4 of the handlers on the backend side were done, and this 5th was remaining. And I think we started work on integrating the backend API in the wallet app. Not sure how much ground we were able to cover, so let's quickly review. Um, First of all, let's run the server so that we know. Let's pull it's already here. Let's close this one. Want to open everything on this workspace. So on these things here. Let's quickly run the server. Before that, let me quickly show my stream is indeed up and working nicely. Okay, it's low away, it's working as well. Nice. I'm just gonna throw this this window with OBS here and launch a new window here. And one thing that I've not done is tweet about this stream actually, so let's get that out of the way as well. Going live with part 7 today. Let's continue building an air gap BIP44 HD Crypto wallet. Let me just copy this link here. Details are here. YouTube link will be this link, and Twitch link will be this link here. Looks good. Tweet, and we're done with that. Close that. Come back to the wallet application we had, and I hope the audio is functioning well. Looks like it is, so that's good. Okay, now that the backend server is running, we were able to fetch the 2 accounts we had. Let's open the MySQL database that we have as well. Okay, looks like we had like 4 actual accounts, and 5th is just a dummy entry. We don't need to worry about that. Okay, so this was the dashboard view, and this is pulling from the backend, and this one is as well. Okay, let's check whether the add account is integrated with the backend API. Looks like it is, and I think that's how we added this one, and then receive. I think we were able to. Hmm, why is it not showing pre-populated option here? Okay, I think we only show those addresses here that have positive balance, and that's why it's not showing up here. Let's quickly verify that. That must be happening. So it's the receive payment screen. So over here, account in Bitcoin accounts. So let's check here. App.Bitcoin accounts. We do have the addresses here. Oh, okay. And since this is about receiving payment, then we haven't, it has no business checking the balance. So it only needs to be able to generate the address for it. So as long as these accounts are extended pub key ones, they will work. And I think this didn't work because I added a limiter earlier in the code so that we are not fetching the balance of all the addresses under the extended pub key. That is why it's not working here. If I search for limit 2 here, yeah, this is why the third one is not being detected. So that one is indeed done as well. Send crypto. Okay. I think I was able to integrate all of the handlers except I left it at the point where I didn't know how to generate the unsigned transaction data. That is where I left it if memory serves me well. Mm, let's see. Account handler. Maybe this was the remaining generate address handler. The handle and cause and everything. Prepare send transaction. Ultimately show the error, and at this point prepare unsigned transaction. So this was what was remaining, and over here we don't have the JSON RPC call remaining for this. Okay, to summarize, uh, on the wallet side of things, the UI is what you see over here, very basic broken kind of a UI, but that's all right for at least making all of this functional. And then on the backend side of things, the API that's running over there, we needed to add a bunch of handlers that we have added, and we have integrated the backend API into this Vue.js app. So wallet app is done till that extent, except that it does not generate any QR code at any like at the points where it is required to do so right now, and it doesn't interact with it doesn't generate the unsigned transaction data. And apart from that, this Go server that's supposed to be talking to our own Bitcoin Core full node It's not doing that as of now. It's simply relying on third-party API, which we will eventually replace with our own core node implementation. And then today, I still haven't figured out how the transactions actually work. I've been busy for the past 3 days to figure out the custom Linux OS for the Vault side of things. To give you a quick update on that, I was able to compile custom Linux OS using a tool called Buildroot, and I was able to boot the Raspberry Pi from that OS. I was able to reach a login prompt and log in, but basically I wasn't able to do anything with it because there were no package inside of it. It was a very minimal build, and I was able to achieve OS size of about 100 megabytes, a little over that, but it has nothing in it, basically the kind of stuff that we want. Our Vault application, the program that we will write, we will start with today, will need to be there. And apart from that, the Linux OS needs to behave in a certain way. It needs to boot up totally into memory and be able to eject the SD card from which it booted, so that when the this application program initializes, it runs. It has no storage medium of any kind to write any data, even temporarily. So that's how we are trying to safeguard it and ensure that the boot instance of the air-gapped vault here is an ephemeral storage, so it is stateless. It doesn't remember when it was booted the last time and put all data or transaction, or it did. Basically, it's stateless. So a lot of work is required on that end. I'll be doing most of, since it's all figuring out a lot of things and then just trying a bunch of things. And so that's something that I'll be doing after the stream from now on. I'll try to stream during the day, and then after that I'll work on this while I figure out the running environment for the Vault here. So today I want to start with uh, the Vault side of things. I know like the wallet app isn't completely finished, but it requires me to figure out a bunch of things before I finish all of those things. So, and I have not figured out the transaction signing part yet. I started looking into it before the weekend that just gone by, but uh, last 3 days, Saturday, Sunday, Monday, went into figuring out the bits and pieces about the custom Linux OS that we require in this case. So today we'll be doing these two things. We'll start with the front end, I would say, and then see what do we need and what sort of backend handlers we will need for this, and keep on building it in that fashion. So let's come back here, kill this server. So this was the wallet, which is a different program, and now we would need the vault, which will be a different program. And over here, yeah, let's start with our main.go file. Package main, func main. We'll copy over all the basic code that we need for running the server. So this much, and let's run this server on 3001. Okay, let's define a hello handler, so that when we start writing handlers, we can simply copy paste this code and make changes inside of it. Now coming back to, oh, this is the backend. I started with a backend, being a backend engineer all my life. Let's see, let's create a static folder under it and basically follow the same structure here. one assets and one index.html. And what do we have inside templates? Basically nothing. So why do we have it? We can get rid of that. Pretty sure we're not sure if, oh, we were using admin minor. Okay, let's do this. Inside of wallet, inside of static, I'm simply gonna copy the index file that we had over here so that we can simply make changes in this one so that we can reuse this. Deleted all of it. So we'll start from this point. Let's give it a main.js file while we are at it. Assets is a folder under static. So let's create that. And then a main.js file over here. And let's see. Don't need this, don't need this. Let's keep these two files on the very left and everything else on this side. So Vault files are here and wallet files are here so that I can just look into those whenever I need to see something. And where's the index.html for the vault? Over here. That goes here. Okay, let's see. We'll need a server name configured to bind itself to this. So let's look into that first. Let's modify this. For here, we added one server for this, right? So we can replicate this. So we got the server, let's listen on 80 port, define the root to be alt static, index becomes the index HTML file, server name is vault, then followed by this URL, and then okay, for location we would need try files URI handler, and the handler will essentially be telling it to rewrite everything to index.html. So that should be it. Let's restart Nginx and simply access Vault here. Actually didn't open up my chat window today. Hopefully both the chat will show up here correctly this time. Yep, looks good. Say hello to whoever is watching and continue with our build. Okay, coming back to the vault, static, index.html. This is the vault. It is okay. Now, what do we want when the vault app shows up? Since it's always the OS that will run this vault is always going to be an ephemeral OS instance, which essentially means it's stateless. we would always have a mechanism of or importing your existing seed phrase so that you can reuse the seed phrase you have and basically restore the wallet in a way, or be able to generate the wallet and show you all those 24 words, and so that you can safely copy them and make you confirm those that you have indeed copied them and accordingly proceed. So air gapped vault. Still haven't finalized on the name of this wallet. So let's just call it air gapped. A friend suggested air trust, but that's a good name as well. But I'm not really sure how I'll name it, considering that all of the cryptocurrency work is gonna be done under this brand, Woodpecker. And by the way, if you wanna read on what this project is about, you can go to woodpecker.com and click on this link, and it will take you a landing page where it's landing page that are set up basically describing what the goals of this wallet system will be. Okay, let's vault. And the very first screen when it will switch on is the slash page, and that will be okay. So in a way, how we did it like this is what we need to do here. At first, what did we have in the header here? This. Okay, this. Then, oh, where is this my header and my footer? Isn't that in the templates? Why didn't it show me all those files? Okay, so the header file is still here and the template is hard coded over here. Okay, that's why. Okay, so I think I'll copy this header and footer implementation to this main.js file here. We'll obviously modify the links and here gapped vault, my header, my footer, da da da. And then in the index.html, we can copy the header and footer bit as well. So we'll copy this vault, and either inside of this, I'll have to provide the title, which will come from here, and the menu links here. The app section goes here, and then I'll have the footer, which is this. And then for the div based on the routes, we'll keep on copying over this code again and again, changing the route here so that we can control the page flows. I mean, right now, that reminds me that even on the wallet side of things, it's a full page load as of now, and not really using the HTML5 state of jumping to different URLs, maintaining the state that way. But we'll get to that later on. Let's see. So we want to give the user two options. So we're gonna use buttons here. Did we use button? Okay, let's copy one of these buttons here. And this will be generate seed phrase. And the second button would be import seed phrase. Okay, this will be the home view for now. We won't really have this link in the menu itself because it's only shown once, and once the seed phrase is imported, then it will initialize and it will not be possible to come back at the screen without rebooting the device, the vault. Okay, so generate seed phrase. So we'll need a view instance of its own, like this one here. Let's actually type it by hand so that I get familiar with it more and more. Then we need to specify the element, and that will be app in our case. Then we need to specify data, the variables that we're gonna have. We'll add those variables here as we go. Then we have the mounted function to fire up some code when the app initializes, and then don't have any computed properties, but let's add it anyway. And then we have methods, and all the methods defined here go under that, and that is it. So the method that we wanted to add here, generate seed phrase. That looks okay. Okay, let's see. When we want to generate the seed phrase, obviously we can do a lot of stuff in the JS side of things, but I think it's better to do on the Go language side because it will be at least faster. Doesn't really make sense. We're not trying to be efficient on the wall side of things. That our entire objective here is to be provide as much security and as much security as it is possible, and reduce our surface area for different attack vectors that can be possible, even though it's very less to begin with considering the architecture that I've chosen. So over this side there will be a generate seed phrase handler. Generate seed, that can be a handler, and replicating this, generate seed phrase. Let's add the API call here, which will be to look like this, but for that first we need to define the backend API in our case, which will be this. Is this being used here? It isn't. Okay, never mind. Just gonna copy this over and paste it here, change that port to 3001, and then axios.post. It will only be a get because we're not trying to send any parameter whatsoever. And then it will be backend API. And the endpoint here was generate seed, and then what else we have to specify here? Okay, then we also specify the timeout that we don't need in this case, because it's not reliant on any other service. Like, it's not going to make a for an HTTP call or any communication with any other server. So it's gonna be quick. We don't need to, the default timeout, whatever it is, will suffice for our use case. So we simply let's see. Okay, I guess then we simply handle the response. Then response. We define the function like this, and then the catch. And then inside of this, let's add it to the console just to take a quick look. Okay, we issue a GET request to this URL. Let's generate what needs to happen over here. For the generate phase, let's go to the code that I have written earlier, which is this. Is it? No, this is not the one. Maybe this one. Yes, this is the one. So over here, we're gonna use these libraries here. Not all of them in one go, but I think these two of them to begin with. We have we want to generate the seed phrase, so that's essentially mnemonic. I think I should call it mnemonic because that's how it's better known. Generate mnemonic. Hmm. I just realized when this Vault app is interacting with its own Go server, that is this backend. Let's copy this. So this looks accurate. So when this is these two things, the backend and the front end will be communicating with each other. I want to be able to maintain the seed phrase, all the sensitive information, just on the backend side, except when it's necessary to show on the client side, this Vue.js app here, and then clear it out of the memory. And over here, I can take certain additional measures so that that's simply not residing, like, it's simply not lying in open like that, even in that particular environment. So the very first time when the mnemonic is being generated, that will happen here, and we have to communicate to that to the user. So we can't really avoid transmitting that sensitive information to it. That is the actual need. So we'll go with that. But just a mental note for myself that I would always want to keep those sensitive bits here and clean them out of the memory as soon as their purpose is done. Okay, let's see. Okay, we were here. So essentially, we are generating a mnemonic. We are generating a wallet for the We also want the user to provide a user passphrase always. So let's see. So essentially, it's just this function, generating a mnemonic from the entropy. And the entropy is something that either we can rely completely on the backend, which is Go language here, which will ultimately rely on the random number generator for that architecture, and that will be cryptographically secure because that's how Go language will choose it. But I had this idea of providing additional entropy from the client side, which can be used along with the entropy that it's already generating to generate the mnemonic. In and one more option that one more idea that I had was being able to generate your own mnemonic using dice rolls. So you would do the dice rolls in real life, and based on what you got on those dice rolls, you will input that into the application, and it will use that and not any entropy of its own to generate the mnemonic. But I think for now, those will be added iteratively. I think that's the best way to go about it. For now, we'll simply rely on the entropy that the backend gets out of the OS, and the OS is gonna use the cryptographically secure uh, random number generator. Just quickly taking a look at something. Rand.read, Go language.